So we have a map also. Map is another concept which is part of the collections, but not showing in the hierarchy when we discussed about all the classes and interfaces. But so the map interface contains the values based on the key and value. So a key and value pair is going to stored in the map. Each key and value pair is known as one entry. That means a map can contain many entries. Entry means a key value pair is one entry. Like that, you can enter multiple entries into the map. And map contains unique keys. So till now we have seen only values you are storing in the list and set collection. But whereas in the map, every value has a reference. So not only values, okay, the value has a reference. That is a map. And why do you need to use a map? Map is useful if you want to search, update, delete elements based on the key. So in the set and list, you have seen only values. There is no reference for that value. But in the map, you have a reference key for every value. So you can have a unique keys, but values can be duplicate. Values can be duplicate, but keys must be unique. And Java map hierarchy is, so this is also available in java.util package. And map and sorted map, and these two interfaces. Map is an interface. Map is an interface. Sorted map is a sub interface. And these are implemented in these three classes: HashMap, linked HashMap, and tree map classes. So map is implemented in the HashMap, linked HashMap, and sorted map and map is implemented in the tree map, same as a set. So map doesn't allow duplicate keys, but you can have duplicate values. HashMap and linked HashMap allow null keys and values, but tree map doesn't allow any null key or value. So map directly can be traversed. First, you need to convert the map into set using key set and entry set methods. Then you can iterate the set. That's how map can be iterated. So HashMap, linked HashMap, and tree map classes. HashMap is implementation of a map, but it doesn't maintain any order. HashMap doesn't maintain any order. Linked HashMap is the implementation of map. It inherits the HashMap and maintains the insertion order. Which order you inserted, same order will be returned to you with a linked HashMap. Tree map is so implementation of map and sorted map, but it maintains the ascending order. So it sorts the entries in ascending order. So that is this map and HashMap. So linked HashMap process. So what are the useful methods of a map interface? Okay, how you can insert an entry into the map, how you can delete the map, entry. How you can join two maps? How can you get all the keys? How can you get all the entries? So let's see one by one. First one is a put method. It is used to insert an entry in the map. So what is the main purpose of put? It will insert the entry into the map. Put all method. So this map is joined with the existing map. So that basically you can insert a specified map with the main one. Put if absent key value. So first it checks condition-based put method. So it inserts the specified value with the specified key in the map if it is not already specified. So remove. It is used to delete an entry for the specified key. Remove object key, object value. It removes the specified values with the associated keys from the map. So basically, it checks the value to at that key. If that specified value is present in this key, then it will be deleted that entire entry. So key set is returns a set of all the keys. It returns a set of all the keys. So that's the key set. Entry set. It returns all the entries. Entries mean key and values, both. So such kind of entries will be stored in entry set. Entry set. Entry set. So this method returns set collection. See, the data type is map.entry. Set. Set. So this key set also returns a set collection. Next, clear method. It is used to reset the map. It is used to reset the map. And contains value, contains key. These two are important. So this contains value method returns true if some value, this value present in the map. The key, the specified key here as a parameter, if it present in the map, returns true. So returns true. That's the contains key, contains value. And equals method. So equals method, see that we have seen this equals method in the object class, string class. Again, you are seeing in the collections also. Because these are objects, right? So obviously you need to compare two objects. You will take this equals method. So that's the equals method, another advantage. There is a for each loop, it read the, so the key and value, and that's the one thing. And get method. So you will give the key and it will fetch for us value. So because keys are unique, right? So whatever the key you specify, that key value it will fetch and give it to us. That's the get. Get or default also, this is the same default value. So it returns the value based on the key which is specified in the map, or default value if the map contains no mapping for the key. So that is the get or default. Next, hash code. Equals method, hash code. Remember, these two are important. So hash code returns the hash code value for the map. Returns the hash code value for the map. Is empty. So the method returns true if the map is empty. Returns false if it contains at least one key. And so these are the very important methods. Other than that, not required much. What is the very important methods for is put method to insert the entry into the map. Put all method to joins two maps. And remove method which deletes the entire entry in the map. And next we have key set. It fetches all the keys from the map and stores in a set collection. There is an entry set. Entry set also returns map set collection. Entry set also returns a set collection which is having all the entries in the set. Then you can iterate them either by iterator or by for each loop. That's how you can iterate the map. Directly, you don't have option to iterate. And next one is contains value, contains key. So this contains key is very useful when you are checking particular key is present in the map or not. Then equals method. So equals method I'm going to use in one of the next topic here only. How HashMap works internally. You should understand equals and hash code method. These two methods I'm going to call there. Anyhow, put and get also I'm going to use, but still, so understand contains value means it checks the value is present or not in the map. Contains key, it checks whether the key is present in the map or not. It's all you need to use with the Boolean if condition. Basically, if condition, you will use these methods. Equals method also, because it returns true or false, right? Whether the specified object is present in the map or not, it will check. So the comparison, basically it compares with other map element. So get object key, the method returns the object that contains the value associated with the key. Hash code, it returns the hash code value of the, so hash code value for the map. So that's the important methods. Other than that, we won't use much. Size also, it returns number of entries in the map. There is one more entry interface. Entry is a sub interface of map. So we will be accessed it by map.entry name. And this interface has a few methods. Get key, get value methods. Get key returns the key. And get value method returns the value. So that's this map.entry interface methods. Each. So in the entry, you have both the key and value, right? You want to know what is the key name, what is the value name. Then you call on that entry, get key method and get value method. You will get the actual values of that key value. That is the map methods. And then let's discuss about classes, HashMap class. So HashMap class implements the map interface by using a hash table concept. It inherits the abstract map class and implements the map interface. How HashMap stores the values, and we are going to read a next topic also very detailed about HashMap, how it will store the entries in the map. We'll discuss. And HashMap class contains values based on the key. Okay. HashMap class contains values based on the key. HashMap class contains values. No, basically it contains only unique keys. As I mentioned, right? Map contains unique keys. HashMap also contains unique keys. HashMap class may have one null key and multiple null values. HashMap class is non-synchronized. HashMap class maintains no order. Initial default capacity of Java HashMap class is 16 buckets. A bucket is nothing but it carries the data, right? So that's the bucket with a load factor of 0.75. That means 3 by 4 is filled. Another 16 buckets will add automatically to the map. So the class declaration is public class HashMap K comma V. K means key data type. V means value data type. So extends abstract map, implements map clonable serializable. So HashMap has four constructors, empty constructor with a map and capacity, and you can give load factor also, you can specify. These are the constructor overloading also occurring here. So these methods we don't need to discuss again. Already we discussed same, right? Okay. So if HashMap is available, why do you need a HashSet? So that's a very important, right? HashSet to HashMap both stores the values using hashing technique only. Hash code value based. That means memory address based, they will store the values. Then what is the difference? Then why do you need a hash map again if there is a hash set? Right? So both have some differences, okay? Both have differences, right? So hash set will store only values, just only values will be there. There is no key reference. HashMap, uses a key value data structure that allows you to store and retrieve values associated with the keys. HashMap is associated each key with a specific value, making it suitable for mapping relationship between key and value. The common use case for HashMap includes storing configuration settings, caching, and representing relationship in data structures like graphs. And so these are the main use cases where you will use HashMap, right? So in your applications, whenever there is a configuration properties, caching mechanism, and also you want to establish the relationship between data structures like graphs. So this HashMap is very useful. When you need to associate values with a specific key, HashMap is a good choice. As already mentioned, map, why do you need a map? If you want to search, insert, delete based on the key, then you will go for map. Such kind of things, if you need to get, HashMap is the good choice. So suppose see here, map string integer, key is a string type, value is integer, A is map, new hash map. So A is map dot put map name, value, the key is Alice, and 25 is the value. See that this is the key and value. So Bob 30. So you can get Alice age. See now, age map dot get Alice. Automatically you will get the age. Alice age is 25. 25 you will get. So that's the map advantage. So next one is HashSet is unordered collection of unique elements. Only values will be there. It's not ordered, but unique. So it definitely use for if you want only unique elements, no duplicate values allowed in your collection, then you can opt for this HashSet. It is often used when you want check for the presence of an element in the collection without regard to its position. Because basically it doesn't work based on the position, right? It's all no. So you can search easily with this HashSet. You can use contains value, right? Contains method you can use and again check. The common use case of HashSet is, so it includes in your implementing sets and ensuring uniqueness in the collection of items. Then you can opt for this HashSet. When you need to maintain a collection of unique elements or efficiently check for the presence of an element, HashSet is a suitable choice. So the syntaxes you know already. Set string unique names equal to new HashSet and unique names dot add Alice and unique names dot add Bob. So contains Alice. Yeah, unique names dot contains Alice. Because it's having only one, right? That's why it immediately tells you whether it is present or not. Efficiently, it will tell us. So in summary of this, while both HashMap and HashSet use hash-based data structure, they have a different purposes. HashMap is used for mapping keys to values, while HashSet is used for maintaining collection of unique elements. So that's the main difference between HashMap and HashSet when you need that. So I hope you got a unique difference now. Any questions on this?
It means only hash map will have keys and values. That means we only need to provide the keys. Whereas in hash set, no keys will be available. Is it, Ramesh?
Yes, you're right. It has only values in the hash set, but unique. Even though if you have duplicate, it will return to you unique elements only.
Okay. That means it will not allow any duplicates.
Any duplicates.
Okay.
It is unordered. Order also not guaranteed because
No.
it's a hash code, right? It will be stored anywhere.
Okay, randomly it might store anywhere. Okay.
Anywhere. But you don't have a option to access randomly the elements, but you can search very easily with the contains method. The element is present or not, you can easily search.
Okay.
That's the main difference between the HashMap and HashSet. Any other questions? Okay. So let's join back quickly and we'll discuss because this topic is very big. I don't want to split this. topic in between, and we can